two projects. In this video, we are going to explain about the project, which is automatic thyroid nodule detection in ultrasound imaging with improved YOLOv5 neural network. So before getting into the execution, first let us understand what is the project about. So what is this thyroid disease? It refers to a variety of conditions that affect the thyroid gland, which is located at the base of the neck. So this gland plays a crucial role in regulating metabolism, energy levels, and overall hormonal balance in the body. Common thyroid disease includes hypothyroidism, where the glands doesn't produce enough hormones, and hyperthyroidism, where it produces too much. Thyroid nodules, which are the abnormal growths on the thyroid, can also occur and sometimes lead to thyroid cancer. So these thyroid nodules are particularly common among adults, especially women, who are 3 times more likely to be diagnosed with thyroid cancer than men. In the last 30 years, the incidence of thyroid cancer has tripled in high income countries, with these nodules often serving as early indicators of the disease. Accurate screening for these nodules is crucial as it can significantly improve the patient survival rates. However, traditional diagnostic methods like fine needle aspiration biopsy, that is FNAB, have notable drawbacks. They can risk damaging nerves or blood vessels, and they are often costly and also frequently yield indeterminate results. So, this leaves patients uncertain about their health and underscores the urgent need for better and safer diagnostic tools for thyroid conditions. So, when it comes to diagnosing thyroid nodules using this ultrasound images, there are some real challenges we face. First of all, these nodules are often small and have vague edges, which makes it hard to detect them accurately. Because of this, a lot of diagnostic process depends on the expertise of radiologists, and that can lead to inconsistencies and misdiagnosis, especially since we are seeing an increase in the thyroid cancer issues. Given these issues, it is clear that we are really in need of an automated diagnostic tool. Such a tool could help improving the accuracy of diagnosis, reducing the number of unnecessary procedures, and also ultimately lead to better outcomes for the patients. So, to tackle the challenges we face in diagnosing thyroid nodules using ultrasound images, we have developed a new system that uses improved version of the YOLO, which is YOLO V5, that is You Only Look Once version 5 neural network. This system is based on the dataset that includes 191 images of the ultrasound images, which helps us to enhance the accuracy of the diagnosis. One of the key features of the system is the addition of coordinate attention module. So this module helps the network focus better on where the important features are located in the images, which improves our ability to identify the nodules. Additionally, we also have integrated the label smoothing regularization module, which helps to prevent the module from beginning to reliant on misleading data by reducing overfitting. Moving forward, to further improve the detection accuracy in this project, we are incorporating the advanced versions of the YOLO, which are YOLO V5X6, YOLO V6, YOLO V8, and V9. These upgrades are designed to improve our ability to analyze and detect thyroid cancer more effectively. On top of that, we have built user-friendly front-end using this Flask framework. So this interface is intended to make sure our testing smoother and more intuitive. We have also included an authentication system to ensure that only authorized users can access tool, adding an extra layer of security. The goal of this extension is to enhance the usability and effectiveness of our automated diagnosis tool. Moving on to implement the project, we have followed the steps of the flow of work. So where we have imported the packages, and these are all the following steps that we have used to implement the project. So first, what we have done is we have imported required packages and libraries into the system. And then we have loaded the images for our dataset to understand what we are working with. And then we have plotted. That means we have visualized the images that to help us get a sense of their quality and the types of defects we might be detecting. After this, we have converted images into blob format, which is suitable for input into a neural network, into our neural network. So this comes under image processing. And then we have defined the classes for the thyroid classification, that is thyroid detection. This step is crucial as it determines what types of thyroid disease that we are looking for. And we set up bounding box, which will help us to identify where the image, where the thyroid disease is detected, that is located. And finally, we convert the images into NumPy array. And we have loaded the pre-trained model and we have focused on the output layer as these will be essential for making predictions based on our input images. Coming to the next step, we have done some more pre-processing. That means we have annotated the images. So here we combine our images with their respective annotations, which will provide information about the defects. And then, as the images are in the BGR format, that is blue, green, and red, we have converted them to RGB. And we have created masks for our images, which will help to isolate the regions of interest for detection. That is for the thyroid gland detection in the ultrasound images. And we have resized the image. And we also did some augmentation where we have done some randomizing. That means we have added some randomness to the images that will help the model to generalize better. And we also rotated the images to simulate different angles of the ultrasound appearances, transforming the image. So additional transformations are applied like flipping, scaling, and brightness, which will enrich our data set. And we also have installed required packages and dependencies. And then we prepared our data specifically for the YOLO, that is you only look once format. So this involves structuring our data in a way that aligns how these models process the input. And then with everything in the place, we construct our YOLO model architecture. This includes defining layers, activation functions, and configuring the model's parameters. So once the model is built, we train it using our dataset. So this process involves feeding the model images and annotations, allowing it to learn to detect the thyroid nodules. Moving on, after training, we save the best performing model. So this saved model is used for further thyroid nodule detection tasks without needing to retrain. And we developed front end using Flash framework, which is integrated with the SQLite database. And in the front end, users they will be able to upload the ultrasound images for detecting the thyroid disease, and that will be pre-processed at the back end. It will be fed with the trained model, and final outcome will be displayed to front end. Moving on to the algorithms used, these are the algorithms used in the project. So this is the proposed model, and these are the extension models. Moving on to the requirements. So we for implementing this project, we need basic hardware and software requirements. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies of HTML, CSS, JavaScript, and Bootstrap. Now we need to execute the project. To execute, we need to open the code folder which contains source code files. So let us open the code folder. So these are the source code files in the code folder of the project. Here in the sample folder, we have some of ultrasound images. We will be using them as a test cases. Coming to static, in this folder we have CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Coming to templates folder, this folder contains all the HTML pages used in the project. They typically include files like index.html, about.html, etc., which represent different pages of the website. And here in the 4 folders, we have the datasets used in the project. So let's open this folder. So here we have two subfolders. One is train and the valid. Let's open the train. Here we have two more subfolders, images and labels. Let us open the images folder. So here we have total 176 images that are used to train the model to detect the thyroid nodules, that is the thyroid disease. These are the ultrasound images. Get back. Coming to the labels folder, here we have files containing annotations or the labels for the objects in the corresponding images. So here each file corresponds to an image in the image folder. For example, the first label file corresponds to first image in the image folder. So it corresponds to this image where it provides the object locations and classes within the image. Similarly, for the second image, we have the second annotation file. Accordingly, for all the 176 images, we have 176 annotation files. Let us open a file. Here, this line specifies the object class index followed by its bounding box coordinates, which are normalized to image dimensions. So this is the object class index and this is the bounding box coordinates. So this is the x limit, y limit, width, and the height. Let us close this. Similarly, we will be having in the all other files also. That is all other annotation files. Coming to the train folder, we will be using images, the annotation files to train the models and the validation to evaluate how the models have performed. Get back. Similarly, in the YOLO V8, YOLO V9, and YOLO V5, we have the same images, but they are annotated differently because each YOLO version requires its own specific type of image annotations for training and testing the models. Having separate folders will help keeping the dataset organized, ensuring that each YOLO version receives the correct annotations it needs to function properly. And this is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the model file, which contains the algorithm information. This will be loaded into the project code during runtime. And here we have notebook.ipynb. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the signup.db file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. Using the command cd followed by the space, paste the copied path and now click on enter. This command will change the current directory to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. So this command, it will execute the Python script and perform a runtime check and syntax errors for all the logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So it is taking time to load. Just wait for a while. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I've copied the link. I prefer Google Chrome, so I will paste it in that. Paste the link and click on enter. This is the web page of the project, which is displayed in the browser. And now we need to click on sign up. Enter all the registration details if you are signing up newly. I have already signed up, so I'll directly sign in. Click on sign in. Provide your username and the password. Click on sign in. So we have redirected to detection page of the project. So here you can see a choose file button, right? We need to click on that for uploading the images. So let's click on choose file. So these are the images that are the test cases. In the sample folder, we will be using them as the test cases in this front end. So let's try uploading the images. So let us upload the first image. Click on open. It has been loaded. Now click on upload. So the image has been processed at the backend and then the train model is fed into the image that we have given. And here we got the detection. So here it has detected as benign and it has drawn a blue color bounding box around the tumor. And here it has labeled it as benign with the 0.85 confidence level. Confidence level is nothing but it is how accurate the detection is in detecting this benign. So it is 85% correct. So here benign means that there is a thyroid nodule, but it will not spread that fast and it is not harmful. So that is why it is classified as benign. It has been classified as benign and it is detected in this part. So this is the ultrasound image. Get back. Let's try uploading some more. Let us upload this image. Click on open, click on upload. And here also we got the prediction as benign. And here it is 87% correct that it is a benign. So this is the ultrasound image and here is the detected part of benign. So here is the thyroid nodule present. Get back. Click on choose file. So let's upload this image. Click on open and now upload it. Here also it has been detected as benign. Let's try uploading some more. Let's upload this one. So here we got the detection of malignant. So here it is drawn in the navy blue color bounding box with the 94% confidence level. And malignant means that there is thyroid tumor here and this will spread, which causes the harmfulness. So it has to be detected and it has to be treated. Let's get back. Let's try uploading some more. So let's upload this image. Here also we can observe that malignant has been detected with the 88% confidence level. Let's get back. Let's try uploading one more image. So let us upload this image. So this is the uploaded image and here we got the detection. So this is the ultrasound image. Get back. In this way, just by uploading images to the application, it will detect the thyroid nodule, whether it is a benign nodule or a malignant. Let's check with the graphs. Click on graph. So here we have FN score graph. And here we have precision recall graph. This is the confusion matrix. Here we have precision score graph where on x-axis we have precision score and on y-axis we have algorithm names. And here we have recall score graph. This is the mean average precision. So these three are the metrics used to evaluate the algorithms which we have built. Click on sign out. In this way, just by giving the images to the application, YOLO model, that is the advanced YOLO model, they will be detecting the thyroid nodule, whether it is benign or malignant. So this will be beneficial for the doctors as well as and also the patients. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.